Okay, hello everybody. My name is Emil, and today's topic we're going to be talking about SQL injection, and basically this is going to be an introduction to SQL injection, some preliminary concepts, and some 101 on database and SQL itself. Um, this presentation was developed in accordance with Florida International University's graduate computer engineering program. Specifically, this is for the ethical hacking class. So, moving on, again, this presentation structure, the first part will be preliminary SQL concepts. What is a database? What are the concepts of tables within a database? What are the commands to access these tables? SQL injection. So in order to understand how SQL injection poses compromises into a system and how it can be turned into something malicious, we need to understand the preliminary concepts of SQL. What I've done is I've created a C# program. This allows us to basically have a controlled environment so that we can see exactly what's going on behind the scenes. So this controlled environment doesn't really reflect the production environment, but conceptually things are very similar. So the first thing we need to understand is what is a database. So by definition, it's basically a structured set of data that was designed to replace a file system in which you would save your data within files. And the benefits of this would be searching upon your data faster, having a layer of language that allows to create, edit, search for that data. One of them being performance as well. A database has the ability to write your data physically close together on the disk. This way it allows for retrieving that data to be very, very, very quick. Now, inside a database, or more specifically a relational database, we have tables. So, for example, moving on to the next slide, I believe showing you guys an example would be the best way to do it. So here is something that I've pasted from Microsoft Excel, and it's actually a very, very good representation of what tables look like within a database. Let's say my database right now consists of 3 tables. The first table is very easy to understand. So we have a users table. Now the columns, or the fields I should say, within this table is something like user ID, first name, last name, email, and password. Now first name and last name, email is pretty much self-explanatory. The user ID is usually something that is unique. So for example, you can have 2 John Does, or you can have 2 Michael Smiths. So the user ID is used to uniquely identify a row. If you notice the table names, I have users, user payment methods, and orders. And forgive me if I didn't mention this earlier, but let's say that this database is basically the back end of an online ordering system. Let's say something like Amazon, for example. So you have a user which you would log in to authenticate with. For this online merchant, let's say you would have multiple payment methods per user. So it's very common for people to have multiple credit cards. So here John Doe has a MasterCard and American Express. Melanie Gonzalez has a PayPal, and Jane Doe has a Discover card. Now, since this is an online merchant, how do we keep track of the history of orders or purchases that a user makes? John Doe, it looks like he's purchased a new camera, a Fuji, PlayStation 4, and another camera here. And basically, this table holds all of the information that is related to the order itself. This is again a very general high-level overview of a database system. I've laid out 3 tables which are hopefully the best example to understand this. Now the next part is, how does my data even get there in the first place? What do I do when I want to search for this data? And what do I do when I want to update this data? Well, we use a language called SQL. So what is SQL, or aka SQL? This basically is an acronym that stands for Structured Query Language, and it's a high-level language. It's very human readable, and what you can do is use SQL commands to retrieve, to update, and to create new records in these tables. What do we mean by a SQL command? This translates to something like, when I want to create data in the orders table, let's say I've logged into my online merchant, I've placed something into my shopping cart, I'm ready to check out. When I click on the checkout button, I'm basically going to go ahead and insert into the orders table. I'm creating a new record. My order ID is 5, my item is going to be a Nikon D800. The price, it's purchased by this guy, eCoba001, the purchase date, and some payment method. So this is basically how I could create a record. Let's say if I wanted to retrieve data. The retrieval process for SQL is given by a select statement. So whenever we see a select, we know that we're going to be grabbing data from the database. The format for a select statement is select the columns that you want to see from the table and then given some condition. With this in mind, let's go ahead and take a look at the example. So I've created a local database and I've called it SQL Injection, and I've created 3 tables: orders, users, user payment methods. Okay, so basically I can write a select statement here to get all of the users or all of the items within this table, and this star denotes give me all columns from this table. Now let's create a new user. From this new query dialog, I'm going to say insert into users, first name, last name, password, username, values, and let's say John Doe. John Doe is his password. JDoe 001. Now if I go ahead and run this, it's going to go ahead and insert into my users table. If I go ahead and take a look at that users table again, I should see 2 rows now. Let's take a look at the user payment methods. Let's take a look at the orders table. Okay, so this is all the elements that's in the orders table. You can see that this online merchant has been selling Fuji cameras, PlayStation 4s, MacBook Airs, home tools, and cameras. These are the users who purchased them. This is the price that they purchased it for, and this is the payment method that they used. Now, since we have an idea of how a table is structured, what are some select statements that I can do, let's say, for example, how many items has eCoba001 purchased in this one? So again, this is where SQL can be very powerful. And here we're basically saying, give me how many items that this guy has purchased. The same could be said about user authentication. So we've all went and visited some sort of online either merchant or social network or any kind of thing where we have our own virtual and personal space or a personal profile or whatnot. Everybody is familiar with some sort of user authentication screen. What is it basically doing for an application that's primarily driven by a database in the back end? So one of the validations that someone could use to authenticate is, okay, when I type in my username and my password, check to see if it even exists in my database. So technically, I could do something like, I'll say count from users, where username equals Koba001 and password equals FIU1234. This statement should return 1. And in my application code, I could say if my select statement has returned 1, then I've quote-unquote authenticated, let the user in. So this is a very simple way of authenticating a user against the database. So with this in mind, let's take a look at now our C# application. Okay, so here's a form. Basically, you would see something like a username and a password text box, and here I am. I'm going to go ahead and type in eCoba001 FIU1234, and I'm going to authenticate, and it's authenticated. If I type in a wrong password, it's invalid. Type in the right password, different username, invalid. So let's go back and let's walk through the code. Now when I click on the authenticate button, what I'm doing is I'm taking the username from my text box. My text box is called text username. My other text box is called text password. And I'm storing them into variables here. So I take these variables, and then what I'm going to do is plug them into a SQL statement here. So something exactly like how we saw, select count from users where username, and I'm concatenating whatever the user has entered into here and whatever the password the user has entered into here. Now, after I execute it, whatever comes back, I'm turning it into an integer, and if that integer is greater than 0, meaning that it does exist in the database, okay, I'm authenticating him. If it is not greater than 0, then it's an invalid. Okay, so the main point in here, and the keyword that I'm using, is that the username and the password in this example gets concatenated to a select statement. So, just like any other languages, there are certain special characters that do something. If I wanted to comment out something, okay, I can simply type in dash dash. So now my condition doesn't really matter about the password. All I need to know is, or all I need to do is plug in something like a username that exists in the database, and it's still going to return 1. So basically I've stripped a condition here, and I could even strip all conditions by typing in another dash dash here. And again, this is just commenting out code, okay? But this commenting the special characters could be used to remove code. And specifically, when we're talking about the where clause, they could be used to remove conditions. They could be very, very, very hurtful if a knowledgeable user purposely comes in here and tries to modify the functionality of a SQL statement by injecting these special characters. There we have it, the concept of SQL injection. So SQL injection could be used to compromise a system by plugging in special characters that would break the query and basically modify it such that it would perform otherwise than intended. So if I know that all it takes to get myself authenticated is for this query to return something that's greater than 0, all I need to do is modify this such that it could. So how do I do that? So I know that inside here, whatever I type is going to go inside here. So let's close this quotation. Okay? Doesn't matter what I put in there. I could put blah 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 or whatnot, but the main part is that I'm closing that quotation. Now that I've closed that quotation, I'm going to say or 1 equals 1. For the rest of the part here to not execute, I'm just going to put in that dash dash to comment out the rest. And basically, we're going to say select count from users where username equals ASDF blah 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 blah, or 1 equal 1. And then that's it. The rest of the stuff doesn't matter. So when I go ahead and click on authenticate, and there we go, authenticated. So just to show the SQL statement, again, select count from users where username equals ASDF blah 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 blah, or 1 equal 1. And then immediately after, the comment, and then all of this stuff here with the password, we don't even care. We just typed in gibberish. So how do we deal with this? The first step that we could do is to filter out these special characters. Let's, if the user types in an equal sign, a quote, 2 dashes, or a dash for that matter, let's filter them out. Let's prevent them from authenticating. So if I check mark this, so if it's checked, basically what I'm going to do is strip the characters and the special characters, and I'm not going to be able to authenticate. See, so I'm clicking here, so somewhere in the routine I'm returning. There is a different approach. Yes, we can go ahead and filter out special characters, but there is a better practice, and that's to use parameters. If you notice here in my form, I had a checkbox here called Use SQL Parameters. And here, if use parameters is checked, or if it's true, notice my select statement is logically the same, but it doesn't involve any kind of concatenation. So what I'm doing here is I'm denoting what is the name of my parameter, and what this SQL CE command will do is bind the value of this variable into here. And whatever we type in here, this select statement will just treat it as a wrong syntax, if anything. But you will not be able to cancel out like how we did with this stuff. So this is why it's always encouraged to use parameters to avoid such things such as SQL injection. Let's go ahead and give this a try. So we know this one authenticates. We know that if we filter out special characters, okay, doesn't happen. If I went ahead and showed this, we see that the quote here is closed. This is, again, this is using concatenation. We haven't shown the example of using the SQL parameters yet, but when we're concatenating, I close this, I say or 1 equals 1, and I syntactically change this query. If I use parameters now, let's take a look at what happens to the query. So first, let's take a look at the query. They will not be treated syntactically, meaning they can't cancel out. It's being treated literally. Therefore, they will not authenticate. Okay, so this is the reason why it's important to use parameters instead of concatenation. So again, this is just a preliminary and a 101 high-level overview of database tables, the language and the layer that's used to retrieve, update, and insert the data. Since we got an overview of the commands to do so, we can see how we can compromise those commands by modifying the syntax of statements. And this example that we've shown is probably the easiest and most common example to understand the concept of SQL injection. And obviously out there are far more complicated cases. So this is just to get our feet wet. And that's pretty much it. So that concludes the presentation for SQL injection. Since this is developed in accordance with Florida International University, all of the content that we've covered and have learned throughout this presentation should be used for educational purposes only. And with that being said, if you guys have any questions, I'd be happy to answer them. Shoot me an email at ecoba001@fiu.edu. And once again, this is Emil. Thanks for watching.